We're in the process of building an MMO. Unfortunately, our game right now is less MMORPG and more MO. So let's improve by working on the G, gameplay. Let's start by actually describing what the gameplay of this game is going to look like. On the macro level, players will walk around various areas interacting with each other. Through these interactions, they'll be joining posses of trained bandits and heading out into the desert wastelands together to find treasure and adventure. On these train journeys, players will operate and maintain their trains by interacting with these puzzle-style minigames. The better the player does in their minigame, the more they contribute to the success of their train's crew. Players will perform minigames for things like navigating, collecting treasure, repairing their train, or even battling other players that they might come across. So, in addition to the MMO features that we've built so far, we're also going to need a system to network these minigames. There'll be simple minigames where players play mostly by themselves but network their score. This will allow the server to ensure they're not cheating, and maintain all the things on the train that it should be maintaining in response to how well the player's doing at their puzzle. But then, there'll also be more complex minigames where players will go head to head against other players or against AI. For this video, let's start with the simpler type of games, since this will allow us to set up the infrastructure for networking these puzzles. When we were planning out this game, I actually built a bunch of different prototypes for different puzzles, and here's the one that we'll be looking at today. It's called Conducting. It's the puzzle that the conductor of your train crew will be performing. The better they do, the faster your train goes. The faster you can find a route from the start to the end of the puzzle, the faster your train will go on its journey. This is a simple first version of this game to start with, and we'll probably add more complexity in the future. We might have bonus points for various tracks if you visit them, or things like locked track segments that you can't rotate. But instead of diving too deep into the gameplay right now, let's focus on the networking. Let's talk about authority. When you're playing an offline game, your device is the only authority. Things happen on your device, and if you cheat, well, it doesn't really impact anybody. As all our mothers used to say, when you cheat, you're only cheating yourself. But when we move into an online game, things get more complex. Let's say we were making a casual party game, like Mario Party. In a style of game like this, players might exclusively connect to their real-life friends. In order to save on server costs, we might have one player acting as the server, hosting the game that all the other players connect to. This is referred to as peer-to-peer multiplayer. This is great for cutting costs, but means that our game is much more exposed to bad actors. If the host wants to cheat, they can. They're the authority. That sounds bad, but in a game like this, it really doesn't matter too much. If you put in effort to cheat at a game like this, your friends will just stop playing with you, or beat you up or something. I guess it depends on your friends, but we don't really care about that. We don't need the game to police you from a technical perspective, since your friends are going to police you from a social perspective. In an MMO, however, we need to be much stricter about authority. Our game server needs to be the authority at all times to prevent cheating. This can be quite restrictive for us as developers, but it really is the only way to securely set up a game with this level of complexity. Let's go back to our conducting minigame. If we were happy with a lower level of authority, we'd allow the client to spawn their minigame and just tell us when they scored points. But again, this exposes us to bad actors. If a player says they're always competing this minigame at peak performance, we can't really stop them. Sure, we can try and detect suspicious activity, like if a player's performing at 100% all the time, but then we're just going to get into an arms race with our hackers, and that sounds really tiring. These arms don't race. Instead, we need our server to be a complete authority over the game. Really, the only thing that our client should be responsible for is telling the server which pieces they're trying to rotate. So, the server creates the board, they send it to the player, and the player responds with what move they're trying to make. The server then looks at that move, updates the board, and sends it back to the player. If a player has a hacked client in this circumstance, all they're really going to do is break their own experience. They'll change things so the game no longer looks like what it does on the server, but the server's the authority, so all they're really doing is cheating themselves. Thanks, Mum. This introduces a lot more complexity, but in quite an interesting way. As an example, this enforces a separation of our game logic, which will only run on the server, and our UI logic, which runs on the client. It's one of the reasons why multiplayer game development can be so rewarding, honestly. It forces you to adhere to a high level of technical quality and code standards. It's fun to learn how neat and tidy your code can be, and multiplayer game development like this really forces you to adhere to that to a much higher extent. Anyway, We've built our first puzzle, and we've set it up in a way that it's compartmentalized and segmented, so the authority over it can be assigned to the server. If we take a quick look, we can see that these scores are being successfully networked, so that feels like a pretty good point to stop for this video. Next time, we'll start building out one of our more complex adversarial games.